Hello students, welcome back to Algebra 2, continuing on with lesson 3.3, solving by completing the square. Now this problem looks familiar to the last one. So in order to solve by using square roots, I would factor the left side into a perfect square and then take the square root of both sides. So I've got x squared minus 10x plus 7 equals 0. So if you try using that same trick that we just did, you'll notice that doesn't work. I'm gonna move off to the side right here. X squared, just kidding, I forgot what it was, minus 10x plus 7. That trinomial does not follow the same pattern that we were using earlier. I wish it did, because if I had x squared minus 10x plus 25, that would be a perfect square, because negative 10 right here is negative 5 times 2. So that means that what I wish this number right here was negative 5 squared, because that would make it a perfect square trinomial. I wish this was a 25, but it's not. It's a 7. But since I have an equation, I can make it into a 25. So I'm going to go back here to my problem, and I'm going to point at this number right here. I wish this were a 25. Well, I can make it a 25. All I have to do to make it a 25 is I'd have to add 18. If I add 18 to 7, it'll turn into a 25. However, being the good algebra students that you are, you know I can't just go adding 18 to equations. In order to do that, I'm going to need to balance it out. That means that I will have to also add 18 to the other side. So now I get this equivalent equation, x squared minus 10x plus 25 is equal to 18. Now I have a nice equation to solve, because x squared minus 10x plus 25 will factor into x minus 5 squared is equal to 18. And now I can proceed to use the square root just like last time. So I will get x minus 5 is equal to, square root of 18. Let's simplify that real quick. That's 2 and 9, that's 3 and 3. So that's the square root of 2 times 3 times 3, but the 3 comes out, leaving me with the 2 on the inside. So x plus 5 equals 3 times the square root of 2, or x minus 5 equals negative 3 times the square root of 2. I'll add 5 to both sides, giving me x equals 5 plus 3 square root of 2, or add 5 to both sides, x equals 5 minus 3 square root of 2. So I can say x equals squiggly 5 plus 3 square root of 2, 5 minus 3 square root of 2, squiggly. That's one correct way of expressing the answer. Now I notice that these two are exactly the same except for the plus and the minus, so I can also say the answer is x equals 5 plus or minus 3 square root of 2, and this is another correct way of expressing that answer. Hello students, welcome back to Algebra 2. We are continuing with lesson 3.3. And now we are going to do an equation where we can solve by completing the square, except this one is going to have a leading coefficient in it. Now this one gets a little bit tricky. So here's what we're going to do. I would like to use completing the square with a trinomial that does not have a leading coefficient. So this trinomial is convenient, because what I could do is just divide the entire thing by 3 and then proceed like normal. However, that's not always the case, so I'm going to use a different technique on it. If you see that you have a problem that you could just divide everything by the leading coefficient and get rid of it, please do that. But in some other cases that won't work. So for example, if instead of this number right here being a 15, if it were a 14, that would completely ruin that technique. So I'm going to show you the harder technique here. So here's what I'm going to do. 3x squared plus 12x plus 15 equals 0. I said 15, but I wrote 5. Okay, I wrote that in a different color because here's what we're going to do. We're going to ignore this third number right here. We're going to ignore the constant. And we're going to focus on just the quadratic and the linear term, the first two terms here. So what I'm going to do here is factor out the leading coefficient. So if I factor that out, the leading coefficient is the 3. That would be 3 times x squared plus 4x plus, and then I'm going to leave a blank space right there. Okay, so right now, there's not a number right there, but I wish there were a number right there. So I'm going to ask myself, what number do I wish were right there? Well, using our perfect square trinomials, I know that 4 is 2 times 2, so that means the number that I wish was right here is 2 squared, which happens to be 4. So that means that x squared plus 4x plus 4 is a perfect square trinomial. Now, just like last time, I can't just add a 4 into my equation without any consequence. I need to balance it by adding to the other side. Now, here's where this gets tricky. I can't add 4 to this side because I didn't actually add 4 to the other side. On the left side of the equation, I added 4, but the 4 was inside the parentheses that were getting multiplied by 3. So by me adding 4 inside the parentheses, I didn't actually add 4, I actually added 4 times 3. So that means that I would actually be adding 12 to each side. On the left side, I added 12 by adding a 4 on the inside of the parentheses where it got multiplied. On the right side, I just directly added 12. So now this is going to look like this. 3, this is going to simplify to x plus 2 squared plus 15 equals 12. Now for this one, I'm going to take a few more steps in order to solve it. I'm going to subtract 15. 3x plus 2 squared equals negative 3. I'm going to divide by 3. And I will get x plus 2 squared equals negative 1. Taking the square root of both sides. And then we remember from our previous lesson that x plus 2 equals I, or x plus 2 equals negative I. Subtracting 2 on both sides, I will get x equals negative 2 plus I, or subtracting 2 on both sides, x equals negative 2 minus I. And since I notice they're both the same with the exception of that sign, I can simplify my answer to x equals negative 2 plus or minus I. And that's my solution. All right, let's go ahead and do one more, slightly more advanced example. This is the same thing, except the equation is not arranged in the way that I would like. So before I move forward, I'm going to just go ahead and subtract 10t from both sides, and I'm going to subtract 14 from both sides. So that's going to give me 7t squared minus 28t minus 14 is equal to 0. Now, just like before, we're we're going to pay attention to these first two. We're going to ignore the constant term. So that means I'm going to have 7t squared minus 4t minus 14 is equal to 0. Now, this is a coincidence, but that's that same trinomial right there. So I've got 7t squared minus 4t, and I know that this is negative 2 times 2 right here. So that means the third number that I want to have right here should be negative 2 squared, which is 4. Minus 14 is equal to 0. Now I just added 4 right there, but I added it on the inside of the parentheses, so that means I need to multiply it by that coefficient right there. So this is going to turn into 7t minus 2 squared minus 14 equals 28. Let's go ahead and solve that. We'll add 14 to both sides. 7t minus 2 squared is equal to 42. Dividing by 7, we get t minus 2 squared is equal to 6. Taking the square root of both sides, we get t minus 2 is equal to plus or minus square root of 6. 6 breaks down into just 2 and 3, so that's actually as simple as it can get. And then I can add 2 to both sides, giving me a final answer of t equals 2 plus or minus the square root of 6.